Hello there, and welcome to The Sleepy Scholar. Tonight's journey takes us into the boundless, unseen world of time itself. Time is the invisible river that carries all things. It is the silence between notes, the space between thoughts, and the slow, patient sculptor of mountains and coastlines. We feel its presence in the turning of the seasons, in the rhythm of our own breath, and in the quiet dust that settles upon forgotten shelves. It asks nothing of us, yet it gives shape to our entire existence. Tonight, we are not here to measure it or to race against it. We are simply here to listen to its oldest stories, to float upon its deep and gentle current as it flows ever onward toward the great ocean of eternity. This journey is one of in-depth wonder. We will explore the curious ways that time stretches and bends, how it whispers to the stars and sleeps within the heart of an atom. We will look at the calendars and clocks that humanity has built, brave little vessels hoping to chart an ocean that has no shore. Each thought is a soft echo, a gentle reflection on the steady, majestic pulse of the cosmos. There is no urgency here, only the calm, steady pace of discovery, unfolding at the speed of starlight. If you enjoy these quiet explorations, consider subscribing so you can easily return here whenever you need to rest. For now, get comfortable, let your eyes grow heavy. Let's begin. The universe itself has a cosmic standard time, which is measured by observing the faint, lingering heat from the Big Bang. This ancient light, known as the cosmic microwave background, or CMB, floods all of space, a gentle echo of creation. As the universe has expanded over billions of years, this light has cooled and stretched, and its present temperature provides a universal reference point. It acts like a great, shared clock for the entire cosmos. An observer anywhere in the universe can measure this background glow and, from its temperature, determine how much time has passed since the beginning. This allows cosmologists to speak of the age of the universe, currently estimated at about 13.8 billion years, as a meaningful concept. It is a time written not in ticking gears, but in the cooling embers of the very first fire. Time literally slows down for objects that are moving very quickly, a phenomenon known as time dilation. This is not a theory, but a measured fact of Einstein's relativity. For an astronaut traveling in a spaceship at a significant fraction of the speed of light, their personal clock would tick more slowly than a clock left behind on Earth. If they traveled for what felt like 1 year to them, they might return to Earth to find that 5 or 10 years had passed for everyone else. This effect is also true for everyday speeds, but the difference is so infinitesimally small that it is completely unnoticeable. It is only when approaching the cosmic speed limit of light that time begins to stretch, to pull like taffy. This bending of duration reveals that time is not a rigid, universal metronome, but a flexible, physical property of the universe, interwoven with space and speed. Gravitational fields can also bend the flow of time, making it pass more slowly in areas of intense gravity. Just as speed can warp duration, so can the immense presence of mass a clock placed at sea level, closer to the Earth's center of mass. Will run slightly slower than an identical clock placed on a high mountain. This effect, though minuscule on Earth, becomes profound near massive objects like black holes or neutron stars. For someone hovering near the edge of a black hole, time would slow to a crawl compared to the outside universe. They might experience only a few hours, while centuries passed for the distant stars. This gravitational time dilation means that your feet are, in a very real sense, aging just a fraction of a second slower than your head. Time, it seems, flows more sluggishly where the gravity well is deepest. The Earth's rotation is gradually slowing down, which means that our days are slowly getting longer. This deceleration is caused by the gentle, persistent pull of the Moon's gravity, which creates the ocean tides. As the Earth spins, the tides act like a subtle brake, dragging against the planet's rotation and transferring a tiny amount of rotational energy to the Moon, pushing it slightly farther away in its orbit. The change is incredibly small, lengthening the day by only about 1.8 milliseconds per century. But over geological ages, this effect is profound. When the dinosaurs roamed the Earth, a day was closer to 23 hours long. Billions of years ago, it was perhaps only 6 hours long. This quiet, gravitational conversation between the Earth and Moon is patiently sculpting our planet's primary rhythm, stretching the measure of our day moment by moment over eons. There is a theoretical shortest possible unit of time, known as Planck time. It is the smallest measurement of time that has any physical meaning, calculated to be about 10 to the power of minus 43 seconds. This is an impossibly brief instant, so short that our human minds cannot grasp it. It is the time it would take a photon, traveling at the speed of light, to cross a distance known as the Planck length, the fundamental quantum unit of space. Below this scale, our current understanding of physics, including space and time, simply breaks down. The very concepts of before and after may cease to apply. It is the fundamental shimmering pixel of the cosmic clock, the indivisible moment in which reality itself is woven. Time, at this most intimate level, may not be a smooth, flowing river, but a series of discrete quantum steps. The smallest fragment of time ever measured by scientists is a zeptosecond, which is a trillionth of a billionth of a second. To visualize this, a zeptosecond is to 1 second what 1 second is to about 31.7 trillion years. Scientists were able to measure this fleeting moment by observing the time it took for a particle of light, a photon, to cross a single molecule of hydrogen. This 2020 experiment, using incredibly precise instruments, allowed physicists to watch the photon interact with the two electrons within the molecule, observing the tiny delay as the light particle passed through. This measurement pushes the boundaries of our ability to perceive the mechanics of the universe. It is a glimpse into the near instantaneous dance of particles that occurs far beneath the threshold of our senses, a world where events begin and end in moments too brief to imagine. The ancient Romans originally had a calendar that consisted of only 10 months, which is why our later months have misleading names. This early calendar, believed to have been established by Romulus, the city's mythical founder, started the year in March and ended in December. This left a gap of roughly 61 winter days that were not assigned to any month at all. The period was simply an unnamed stretch of winter, a time when state and military affairs paused. The names September, October, November, and December, which mean the 7th, 8th, 9th, and 10th month respectively, made perfect sense in this 10-month structure. It was only later that the months of January and February were added to the beginning of the year to properly account for the winter, shifting those numbered months out of alignment with their names, a mismatch we have inherited to this day. Before the invention of mechanical clocks, humanity relied on a fascinating variety of timekeeping devices. The most common were sundials, which tracked the shadow of a gnomon as the sun journeyed across the sky, a silent, sun-drawn map of the day. But for cloudy days or the long hours of night, other measures were needed. water clocks, or clepsydras, were used in ancient Egypt and Greece. These were vessels from which water dripped at a constant, slow rate, with markings on the inside to show how much time had passed. In other places, people used marked candles that burned at a predictable speed, or hourglasses filled with fine sand, letting gravity itself pull the moment steadily downward. These early clocks were not just tools, but physical manifestations of time's passage, measuring the hours in water, fire, and earth. The concept of a week is almost entirely a human invention and has no direct basis in astronomy, unlike the day, the month, and the year, which are defined by the physical motions of the Earth, Moon, and Sun. The 7-day week is a purely abstract rhythm. Its origins are ancient, likely stemming from the Babylonians, who held the number 7 as sacred. This number corresponded to the 7 celestial bodies they could see with the naked eye: the Sun, the Moon, Mars, Mercury, Jupiter, Venus, and Saturn. This 7-day cycle was adopted by the Jewish people for their religious observance, creating a rhythm of 6 days of work and 1 day of rest. This structure was later adopted by Christianity and Islam, and eventually spread globally through Roman and European influence. The week is a testament to our human need to organize time, to create a smaller, more manageable rhythm within the vast, turning cycles of the cosmos. There is a clock in London, the Corpus clock, that is designed to be intentionally unsettling, to remind viewers of time's passing. Unveiled in 2008, it has no hands and no numbers. Instead, it displays time by opening and closing small slits in its face, which are lit from behind by blue light, revealing the hour, minute, and second in 3 concentric rippling circles. Perched atop the clock is a large menacing sculpture of a grasshopper-like insect, which moves its jaws, appearing to eat the minutes as they pass. This creature, called the chronophage or time eater, rocks back and forth, and every hour, on the hour, it lets out the sound of a rattling chain. The clock's inventor intended it to be a piece of public art that disrupts our passive acceptance of time, a beautiful and frightening reminder that each moment is precious and once gone, is consumed forever. The New Year has been celebrated at many different times of the year by different cultures throughout history. The modern celebration on January 1st was set by the Roman calendar, specifically when Julius Caesar reformed it in 46 BC. He chose January because the month was named for Janus, the two-faced god of beginnings, doorways, and transitions, who could look both backward into the old year and forward into the new. Before this, the Roman New Year had been in March, which was the beginning of spring and the start of the campaigning season for the military. In many other cultures, the New Year was, and still is, tied to natural cycles. The Lunar New Year in East Asia, the spring equinox for the Persian Nowruz, or the autumn harvest for ancient Celts, all mark time's renewal. The date of the new year is a choice, a cultural decision on where to place the pin in the great turning wheel. The concept of a minute or second as a fixed division of time is a relatively recent invention. Ancient civilizations, such as the Egyptians and Greeks, divided the daylight and the darkness into 12 hours each. However, this meant that a daylight hour in the summer was much longer than a daylight hour in the winter. These were not fixed durations, but temporal hours, or 1/12 of the available light or dark. It was only with the invention of the first mechanical clocks in 14th century Europe that the idea of a fixed equal hour became common. These clocks, driven by weights and gears, ticked at a steady pace, independent of the sun. This new mechanical time made it practical to divide the hour into 60 smaller parts, the minuta prima, or first small part, and then divide that again, the minuta secunda, or second small part. This is where our modern minutes and seconds come from, born from the steady pulse of a machine. The French Republican calendar was a bold attempt to completely redefine and decimalize time during the French Revolution. Introduced in 1793, it was a radical break from the past. Designed to remove all religious and royalist influences, the calendar started its year one on the founding of the French Republic. It featured 12 months, each with a new poetic name based on nature, such as Brumaire for the month of fog, or Floréal for the month of flowers. Each month was divided into 3 10-day decades instead of 7-day weeks, eliminating Sunday. Even the day was decimalized. It was divided into 10 hours, each hour into 100 decimal minutes, and each minute into 100 decimal seconds. This logical base 10 system proved too difficult for the public to adopt and was abandoned by Napoleon in 1806. It remains a fascinating monument to the idea that time itself could be reshaped by human will. The most accurate clock ever built is the atomic clock, which will not gain or lose a single second in over 15 billion years. These remarkable devices do not measure time with gears or pendulums, but by the ticking of atoms themselves. They work by using the precise, unvarying frequency of radiation that is emitted or absorbed by an atom, such as cesium or strontium. When its electrons change energy levels, this frequency is so stable and so predictable that it has become the international standard for defining what a second is. Atomic clocks are the hidden heartbeat of our modern world, essential for a vast network of technologies. They synchronize the internet, allow GPS satellites to pinpoint your location, and coordinate global financial transactions. They are the quiet, invisible rulers that keep our interconnected civilization running perfectly in time, all by listening to the patient, quantum whisper of an atom. Some languages, like the Hopi language of North America, have no past, present, or future tenses for their verbs. This linguistic structure, studied by linguist Benjamin Whorf, suggests a concept of time profoundly different from that of English or other European languages. Instead of dividing time into a linear sequence of what was, what is, and what will be, the Hopi language appears to focus on the nature of the event itself. Verbs are inflected based on whether an event is known to have happened, is happening now, or is expected or dreamed to happen. This creates a worldview based less on a timeline and more on a manifesting reality, where the now is a collection of all things that have been physically realized, while the future remains in a state of potential, a realm of hope and thought. It suggests that the very language we speak helps to build the reality of time we experience. In the 19th century, every town in America had its own local sun time, which caused chaos for the new railroad system. Before standardization, time was a local affair. When the sun was at its highest point in the sky, it was noon in that town. But noon in Philadelphia was several minutes different from noon in New York City, and different again from noon in Boston. For a person walking or riding a horse, this difference was irrelevant. But for the railroads, trying to run complex schedules over vast distances, this patchwork of local times was a logistical nightmare. A train conductor's watch would be correct in one town and wrong in the next, leading to confusion and dangerous collisions. This problem forced the railroad companies to act, and in 1883, they unilaterally established the 4 standardized time zones: Eastern, Central, Mountain, and Pacific, that we still use across North America today, imposing a new unified railroad time upon the continent. The first ever photograph of a human being was captured purely by accident, because he stood still long enough for time to see him. In 1838, Louis Daguerre took a photograph of a boulevard in Paris using his new invention, the daguerreotype. The exposure process was incredibly long, lasting perhaps 7 to 10 minutes. Because of this long duration, the bustling street, full of moving carriages and pedestrians, appears completely empty and deserted. All that motion was too fast to be registered by the slow chemical plate, and it all vanished into a blur. However, in the lower left corner of the image, one can clearly see a man. He was, by chance, having his boots shined. This simple act required him and the boot shiner to remain almost perfectly still for the entire exposure, making them the only 2 people on that busy street to be fixed in time, their images unknowingly becoming the first ghostly portraits of humanity. There is a 4,000-year-old tree in California that is one of the oldest living things on Earth, a living monument to deep time. This tree is a Great Basin bristlecone pine, located high in the White Mountains, given the name Methuselah. It germinated around 2833 BC, meaning it was already a sapling when the Great Pyramids of Giza were being built. It was alive during the rise and fall of the Roman Empire, the entire span of the Middle Ages, and the dawn of the modern era. This ancient being has survived by living in an incredibly harsh, cold, and dry environment where it grows with agonizing slowness, its wood becoming dense and resinous, resisting rot and insects. To stand in its presence is to feel the profound, slow patience of biological time, a life measured not in years, but in millennia, a silent witness to almost the whole of human civilization. A single day on the planet Venus is longer than its entire year. This is the strange reality of a world that spins backwards, lost in a slow and heavy waltz, while Earth turns with familiar speed. Venus performs an incredibly slow rotation, taking about 243 Earth days to complete just one turn on its axis. Yet, this neighboring planet moves more quickly in its orbit, completing a full journey around the Sun in only about 225 Earth days. This means its day, the time it takes to spin once, is measurably longer than its year, the time it takes to circle the Sun. This slow, retrograde motion is a profound celestial mystery, perhaps the scar from a colossal ancient impact that forever altered its rhythm. It serves as a reminder that time does not flow at one universal pace, but is a unique measure for each world, a private song that each planet hums to itself in the quiet dark. The present that we experience is not an instantaneous point in time, but a smeared out duration of about 2 to 3 seconds. This is the conclusion of neuroscientists who study our perception of now. Our consciousness does not operate like a high-speed camera, capturing one instant at a time. Instead, it gathers and integrates sensory information, sights, sounds, and feelings over a short window of time. It then presents this information to us as a single, unified present moment. This is why a musical melody makes sense. We are hearing not just the current note, but also holding on to the notes that just passed. This perceptual present is the necessary buffer that allows our brain to process the rush of reality and build a coherent story from it. Our entire conscious experience, it seems, is not of the precise now, but of the immediate, fading just was. A person's chronotype, or their natural tendency to sleep and wake at a certain time, is largely determined by their genetics. This internal timing, often described as being a morning lark or a night owl, is a deeply ingrained biological trait. It is regulated by our circadian rhythm, the body's master clock located in the brain, which is influenced by a set of clock genes. These genes control the daily cycles of hormone release, body temperature, and metabolism. While a person can partially shift their schedule with effort and light exposure, their fundamental chronotype remains remarkably stable. This is not a matter of choice or personal discipline, but a genetic inheritance, as much a part of them as their eye color. It is a reminder that each body keeps its own sacred time, a personal rhythm inherited from thousands of generations who adapted to the turning of the day and night. The shortest-lived known particle, the Z boson, exists for only about 10 to the power of minus 25 seconds. That is thousands of times shorter than even a zeptosecond, the tiny unit of time we met earlier. The Z boson is one of the fundamental particles that carries the weak force, the force responsible for certain types of radioactive decay. It is so massive that it can only be created in high-energy collisions, such as those in a particle accelerator like the Large Hadron Collider once formed. It exists for this unimaginably short duration, before decaying into other, more stable particles. Its brief life is not a flaw, but its entire purpose. It is a bridge, a momentary handshake between other particles, transmitting force and information before vanishing back into the quantum foam. This fleeting existence is a fundamental part of the universe's machinery, a tiny, vibrating echo in the grand symphony of reality, lasting for just an instant. The Julian calendar, introduced by Julius Caesar, made a tiny miscalculation in the length of a year, which added up to 10 full days by the year 1582. The Julian system defined a year as exactly 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, the time it takes for the Earth to orbit the Sun, is just a little bit shorter, 365.25 days, which it accounted for by adding a leap day every 4 years. However, the true solar year, at about 365.2422 days. This tiny difference, just over 11 minutes per year, seems insignificant, but over the centuries it accumulated. By the 16th century, the calendar had drifted so far that the spring equinox, which should have fallen around March 21st, was happening on March 11th. This caused problems for the Catholic Church in calculating the date of Easter. To fix this, Pope Gregory XIII introduced the Gregorian calendar, which simply skipped 10 days in October 1582 and refined the leap year rule, bringing time and the seasons back into alignment. The international date line is not a straight line, but zigs and zags across the Pacific Ocean to avoid splitting countries into 2 different days. This imaginary line, running roughly along the 180-degree longitude meridian, is the agreed-upon boundary where one calendar day officially ends and the next one begins. If it were perfectly straight, it would slice through several island nations, meaning one village could be having breakfast on Tuesday, while a village a few miles or kilometers away would be having breakfast on Monday. To prevent this confusion, the line was drawn with large detours. It famously bends far to the east to keep all of the nation of Kiribati in the same day, making it one of the first places on Earth to welcome the new year. The line is not a physical law, but a human agreement, a negotiated truce with the unceasing spin of the planet. Some trees, like aspens, can form a single massive colony connected by one root system, making them thousands of years old. The most famous example is Pando in Utah, a colossal colony of a single quaking aspen above ground. Pando appears to be a forest of over 40,000 individual trees, but underground, they are all clones, stems growing from one vast interconnected root system. This single genetic organism is estimated to be over 80,000 years old, though some estimates are more conservative. Placing it closer to 14,000 years, it has survived by sending up new stems as old ones die, effectively regenerating itself over millennia. This makes it not only one of the heaviest known living things, weighing an estimated 13 million pounds or nearly 6 million kilograms, but also one of the oldest. Pando is a living testament to a different kind of time, a slow, sprawling, clonal immortality that quietly endures. The arrow of time, the reason time seems to only move forward, is one of the biggest unsolved mysteries in physics. On the level of individual particles, the laws of physics are almost entirely time reversible. This means that a process, like two particles colliding, would look perfectly valid if it were run backward in time. But in our large-scale world, this is not true. A broken egg cannot reassemble itself. Smoke does not flow back into a fire. This one-way direction of time is understood through the concept of entropy, the idea that systems naturally move from a state of order to a state of disorder. The universe began in a highly ordered, low-entropy state at the Big Bang, and it has been moving toward a state of greater disorder ever since. This unwinding of cosmic order is what we perceive as the forward flow of time, a universal, irreversible sigh of the cosmos expanding into its own future. The cicada insect spends almost its entire life waiting in darkness, a creature whose life is a monument to patience. There are two types of cicadas, annual and periodical. The periodical cicadas, found in North America, are the most remarkable. These insects emerge in massive broods, but only after living underground as nymphs for exactly 13 or 17 years. During this long, hidden life, they feed on sap from tree roots, slowly growing and counting the passage of seasons. Then, in one spring, guided by a mysterious internal clock, the entire brood burrows to the surface simultaneously. They shed their nymphal skins, live as winged adults for just 4 to 6 weeks to mate and lay eggs, and then their brief time in the sun is over. This precise prime-numbered life cycle is a brilliant evolutionary strategy, a way to emerge in such overwhelming numbers that predators cannot possibly eat them all, ensuring the survival of the next long-waiting generation. Leap seconds are occasionally added to our official global time to keep our atomic clocks in sync with the Earth's slowing rotation. While atomic clocks, which define Coordinated Universal Time, or UTC, are incredibly precise, the Earth itself is not. As we've seen, the planet's spin is subtly slowing down, due to the moon's tidal pull. This means that atomic time is slowly but steadily pulling ahead of astronomical time, which is based on the Earth's rotation. To prevent this drift, an international body decides when to add a leap second to the global clock. This usually happens on June 30th or December 30th. On that day, the clock ticks from 23:59:58 to 23:59:59, then to the unusual time of 23:59:60, before finally ticking over to 00:00:00. These tiny adjustments are a necessary patch, a way to reconcile our perfect mechanical time with the ancient organic time of our own spinning world. The human brain is able to edit our perception of time, stretching or compressing moments based on our experience. This is why time seems to speed up when we are having fun, and why it seems to drag on forever during a moment of fear or boredom. When we are in a new or frightening situation, our brain goes into a high-resolution mode. The amygdala, which processes emotion, becomes highly active and instructs the hippocampus, the memory center, to record every possible detail. This density of information makes the memory of the event seem much longer in retrospect. Conversely, when we are in a familiar routine, our brain is efficient. It doesn't need to record all the details, so it creates a much simpler, more compressed memory. This is why childhood, a time full of new experiences, often feels so long in our memory, while routine adult years seem to fly by in a blur. The Great Vowel Shift was a slow, centuries-long change in the English language that is the reason our spelling is so strange today. Between the 1400s and 1700s, the pronunciation of all the long vowels in Middle English gradually changed. For example, the word mouse was once pronounced moose, and the word geese was pronounced gesse. The word boot once rhymed with the modern word boat. This massive linguistic shift happened slowly, over many generations, at the very same time that the printing press was standardizing the spelling of English words. Because the spelling became fixed while the sounds were still changing, a great disconnect opened up between the written word and the spoken word. The silent E on the end of words like name is a fossil of this, a relic from a time when that E was actually pronounced, a quiet echo of a language that has long since faded from speech. The concept of jet lag is a direct result of our biological clocks being unable to keep up with high-speed travel. Every cell in our body has its own internal clock, all of which are coordinated by the master clock in our brain. This master clock, the suprachiasmatic nucleus, is synchronized by the daily cycle of light and dark from our environment. It tells us when to feel sleepy, when to be alert, and when to digest food. When a person crosses several time zones in just a few hours, their internal clock is suddenly in conflict with the new external time. The sun may be rising in the new location, telling the brain it's time to wake up, but the body's internal clock, still on its original schedule, is screaming that it is the middle of the night. This profound desynchronization is what we feel as jet lag, a deep fatigue and disorientation as our entire biology slowly, painfully tries to reset itself to the new sun. The Maya civilization developed one of the most complex and accurate calendar systems in the ancient world. They did not have just one calendar, but a series of interwoven cycles that tracked time on different scales. The most important were the 260-day sacred calendar called the Tzolkin, and the 365-day solar calendar called the Harb. These two calendars ran together like two interlocking gears to create a larger 52-year cycle, but they also tracked a long count, a linear calendar that measured time from a mythical starting point corresponding to the year 3114 BC. This long count is what famously completed a major cycle in 2012. The Maya were brilliant astronomers, and their calculation of the length of the solar year was, in some ways, even more accurate than the Julian calendar used in Europe at the time. They were true masters of time, viewing it not as a simple line, but as a vast, repeating, and sacred cosmic pattern. The light we see from the Andromeda Galaxy, our closest spiral neighbor, is over 2.5 million years old. This means that when we look up at that faint, fuzzy patch of light in the night sky, we are not seeing the galaxy as it is now. We are seeing it as it was 2.5 million years ago, the time it has taken for its light, traveling at the fastest speed possible, to cross the immense void between us. When that light began its journey, modern humans did not yet exist on Earth. This look-back time is a fundamental concept in astronomy. The farther we look out into the cosmos, the deeper we are looking back into time. The most distant galaxies we can see with our best telescopes are shown to us as they were over 13 billion years in the past. Their ancient light serving as a baby picture of a universe that was only just beginning. A jiffy is not just a vague saying, but is used in computing and physics as a real defined unit of time. Its definition, however, changes depending on the context. In computer science, a jiffy is the duration of one tick of the system's timer interrupt. This can vary between different operating systems, but it might be 1/100th or 1,000th of a second. It is the smallest time slice that the computer's processor uses to divide its attention between different tasks. In physics, the term has been used to describe the time it takes for light to travel 1 Fermi, which is the size of a nucleon, an incredibly small distance. In this context, a jiffy is about 10 to the power of -23 seconds. In all its forms, it represents a tick, the smallest practical unit of time relevant to a specific system, whether that system is a microchip or a particle. The speed of light, the ultimate speed limit of the universe, is not technically a speed, but a fundamental property of the geometry of space-time. We measure it as about 186,000 miles per second, or roughly 300,000 kilometers per second. But according to Einstein's relativity, this value, c, is more profound. It is the conversion factor between space and time. It is the speed at which all massless particles must travel. More strangely, it is a speed that is measured as being the same by all observers, regardless of how fast they are moving relative to each other. This constancy is the bedrock of relativity. It means that if you are traveling in a spaceship and turn on a flashlight, you will measure the light moving away from you at speed c, and a person standing still on Earth will also measure that same beam of light moving at speed c, a paradox that is only resolved if time and space themselves are flexible. The entire history of the universe can be compressed into a single cosmic calendar to help visualize its immense timescale. In this popular analogy, created by the astronomer Carl Sagan, the 13.8 billion year history of the cosmos is mapped onto a single calendar year, from January 1st to December 31st. On this scale, the Big Bang happens in the first instant of January 1st. The Milky Way galaxy doesn't form until May. Our own solar system and the Earth are latecomers, appearing only in early September. Life on Earth begins around September 21st. The dinosaurs first appear on Christmas Eve, December 24th. and they roam the Earth for 3 days before going extinct on the 28th. The entire recorded history of humanity, all our empires, wars, and art, fits into just the last 14 seconds before midnight on New Year's Eve. The life of a single human is but a fraction of a second in this great cosmic year. The phenomenon of déjà vu is believed to be a brief timing error in the brain. This is the uncanny, fleeting feeling that you have already seen or already lived a moment that is happening right now. While the exact cause is still debated, a leading theory suggests it is a momentary hiccup in memory processing. Normally, sensory information flows into the brain and is processed simultaneously by the centers for perception and the centers for memory. However, a tiny millisecond delay in one of these pathways could cause the brain to receive the perception signal just an instant after it receives the memory signal. This split-second error tricks the brain's memory system into flagging the brand new incoming experience as an old memory. It is not a glimpse into a past life, but a neurological echo, a brief, harmless confusion in the brain's intricate filing system. The ancient Greeks had 2 different words for time, chronos and kairos. Chronos is the time we are most familiar with. It is sequential, measurable, and quantitative. It is the time of clocks, calendars, and deadlines. It is the ticking of the seconds, one after another, in a relentless, linear march. Kairos, however, is a different concept. It is qualitative time. It refers to the right moment, the opportune time, the supreme moment for action or decision. It is not about the duration, but about the quality and significance of the moment itself. Kairos is the moment when a great idea strikes, the critical instant in a battle, or the sudden, fleeting window of opportunity. While Chronos is the ocean, vast and indifferent, Kairos is the perfect wave that a sailor must be ready to catch. Our lives are lived in Chronos, but they are defined by Kairos. Some animals, like the hummingbird, experience time at a much faster rate than humans do. This is related to their incredibly fast metabolism. A hummingbird's heart can beat over 1,200 times per minute, and its wings can flap 80 times per second. To navigate their world and catch tiny, fast-moving insects, their brains and eyes must process information at an incredible speed. This is measured by critical flicker fusion frequency, the speed at which a flickering light is perceived as a steady, continuous glow. For humans, this is about 60 Hz. For a hummingbird, it is much higher. This means that a motion that would look like an impossibly fast blur to us, like the wings of another bird, might appear to them in slow, clear detail. They live their lives in a permanently accelerated bullet time, a world of detail and speed that our slower perceptions can never access. The twin paradox is a famous thought experiment in physics that illustrates the strange reality of time dilation. It imagines 2 identical twins. One twin stays on Earth, while the other embarks on a long journey in a rocket traveling near the speed of light. The twin in the rocket experiences time moving much more slowly due to their incredible velocity. They travel for what feels like a few years, then turn around and return to Earth. However, for the twin who remained behind, decades have passed. When the traveling twin steps out of their ship, they are still young, while the earthbound twin is now elderly. This isn't a true paradox, but a consequence of the traveling twin undergoing acceleration, which breaks the symmetry. It's a profound demonstration that time is not absolute. Its passage is a personal journey, measured differently by every traveler, and forever linked to the path one takes through space-time. Plants possess incredibly precise internal clocks that allow them to anticipate the daily cycle of the sun. This internal circadian rhythm is not just a passive reaction to light. It is a predictive engine. Long before the first light of dawn, a plant is already preparing for photosynthesis. It begins to produce the necessary enzymes and unfurl its leaves to capture the expected sunlight. This internal timing allows the plant to maximize its energy generation. If a plant is kept in constant darkness, it will continue to follow this internal 24-hour cycle for several days, raising and lowering its leaves on schedule. This mechanism, driven by a complex feedback loop of genes and proteins, is a testament to life's deep attunement to the planet's rotation. The flower that opens for the morning sun and closes at dusk is not just a mechanism. It is a quiet keeper of time, a living sundial that has learned to dance in perfect rhythm with the day. The world's longest continuously running laboratory experiment has been patiently measuring time and viscosity for over 90 years. This is the pitch drop experiment, which began at the University of Queensland in Australia in 1927. It was designed to demonstrate that pitch, a type of tar that appears solid and can be shattered with a hammer, is actually an extremely viscous liquid. A sample of pitch was heated and poured into a sealed glass funnel, and in 1930, the funnel's stem was cut, allowing the pitch to begin to flow. In the nearly 100 years since, only 9 drops have fallen, each one a major event. The 8th drop fell in 2000, and the 9th in 2014. For most of its history, the experiment was so slow that no one had ever seen a drop fall in real time until modern cameras in the 21st century finally captured the moment a drop detached. It is a profound meditation on patience, a process that operates on a timescale far slower than a human life, reminding us that even solid-seeming things are in a state of slow, imperceptible change, given enough time. A common housefly perceives the world in extreme slow motion, which is why they are so difficult to swat. Like the hummingbird, a fly's experience of time is dictated by its metabolic rate and its flicker fusion frequency. A fly's eyes can process visual information at a rate of about 250 frames per second, or hertz. In comparison, the human eye processes only about 60 hertz. This means that to a fly, our world is moving at roughly 1/4 speed, a rolled-up newspaper descending towards it, which seems fast to us, appears to the fly as a slow, predictable object, drifting leisurely through the air. This gives it an abundance of time to calculate an escape route, clean its legs, and fly away before the threat even arrives. Their buzzing, frantic movements are not chaos to them, but calm, deliberate actions in a world that moves with the pace of a dreamtime. For the fly is a river that flows 4 times more slowly. In 1752, the British Empire lost 11 days from its calendar overnight. This was not a mystical event, but a long overdue administrative correction. Britain and its colonies were still using the old Julian calendar, which, as we've seen, had drifted significantly out of sync with the seasons. Most of Catholic Europe had already adopted the more accurate Gregorian calendar back in 1582. By 1752, the British calendar was 11 days behind. To finally align with the rest of Europe and the true solar year, Parliament passed an act. It declared that the day after Wednesday, September 2nd, 1752, would be Thursday, September 14th. The 11 days in between simply vanished from the calendar. This sudden leap forward caused public confusion, with some people reportedly chanting, "Give us back our 11 days." It was a stark reminder that time, as we measure it, is ultimately a shared agreement, a system that can be edited and rearranged by human decree. Radioactive decay is governed by a precise, unchangeable clock known as half-life. For any single unstable atomic nucleus, its moment of decay is completely random and unpredictable. We can never know when a specific atom will transform. However, for a large collection of these atoms, a statistical certainty emerges. The half-life is the fixed amount of time it takes for exactly half of the atoms in a sample to decay for carbon-14. This is about 5,730 years. For uranium-238, it is about 4.5 billion years. This clock is impervious to temperature, pressure, or chemical conditions. It is an absolute property of the nucleus. This immutable, patient ticking is the foundation of radiometric dating, allowing us to listen to the whispers of ancient artifacts and the deep geological time of the Earth itself, all by counting the steady, predictable echoes of atoms transforming. The concept of a 2-day weekend is a very recent social invention, born from industrial labor and religious compromise. For most of human history, time was divided simply into working days and a single day of religious rest, which was Friday for Muslims, Saturday for Jews, and Sunday for Christians. In 19th century Britain, industrial factory workers were often overworked, leading to an unofficial and often disruptive tradition of Saint Monday, where workers simply wouldn't show up on Monday to recover. To create a more stable workforce, factory owners began to give workers a half-day off on Saturday. This, combined with the Sunday day of rest, formed a new pattern. The idea was later championed by labor unions and, famously, by Henry Ford in the 1920s, who adopted the 40-hour, 5-day workweek, arguing that it increased productivity and gave workers leisure time to become consumers. This small, protected island of rest at the edge of the working week is not a natural law of time, but a hard-won modern structure built to give our lives a new and necessary rhythm. Our brain must actively timestamp our memories to keep them in the correct order. When you recall a memory, you are not just pulling up the event itself, you are also pulling up its tag, its place in your personal timeline. This sense of when something happened is crucial for a coherent autobiography. Neurologists believe this process is managed by the hippocampus, the same region that forms the memories. It not only encodes the what and where, but also the when. It does this by creating a unique neural signature, or context code, for each experience. This code is linked to the state of the brain at that moment, which is constantly, slowly drifting. By tagging the memory with this time code, the brain can later retrieve a sequence of events and place them in the correct order. Without this internal clock, our past would be a chaotic, jumbled library of moments with no sequence, no story. Our personal timeline is a narrative that our brain must patiently write, moment by moment. The deep-sea zombie worm can take decades to mature, living on a timescale that matches the decay of a whale. When a great whale dies, its massive body sinks to the dark, cold ocean floor, a process known as a whale fall. This single event provides a sudden feast of nutrients in the barren deep. Among the creatures that arrive are the Osedax worms, sometimes called zombie worms. These bizarre, plant-like creatures have no mouths or stomachs. Instead, the females anchor themselves to the whale bones, secreting an acid to dissolve the bone and releasing a network of roots, that harbor symbiotic bacteria. These bacteria digest the fats and oils trapped inside the bones, feeding the worm. The worm's life is tied directly to this slow-release meal, a process of decay that can take 50 to 100 years. The worm matures, reproduces, and lives its entire life in this slow, dark banquet, a creature whose internal clock is synchronized not with the sun, but with the patient, 100-year sigh of a skeleton returning to the sea. The world's time was standardized at an observatory in London because of the need to solve the problem of longitude at sea. For centuries, sailors could easily find their latitude by observing the sun or stars, but finding their longitude, their east-west position, was incredibly difficult. It was a problem of time. To know your longitude, you need to know the precise time at your home port and compare it to the local time on your ship, found by observing the sun at noon. The difference in time tells you your position. This required an incredibly accurate, portable clock that could withstand a long sea voyage, a chronometer. In 1714, the British government established the Royal Observatory at Greenwich and offered a massive prize to solve this problem. Greenwich was chosen as the prime meridian, the 0-degree line of longitude, and its local time, Greenwich Mean Time, became the standard reference for all maps and ships. The entire grid of global time zones was born from this nautical need, an imaginary line drawn through a London suburb to anchor the world's restless oceans to a single, steady clock. The problem of longitude at sea was finally solved by a humble, brilliant clockmaker named John Harrison, who built a timepiece that could keep perfect time on a moving ship. For centuries, the lack of a reliable chronometer was the greatest danger of sea travel. In 1714, the British government offered a prize worth millions in today's money to anyone who could solve it. While great astronomers looked to the stars, Harrison, a carpenter's son, believed the answer was a machine. He devoted his entire life to this singular challenge. His fourth and most famous creation, the H4, was his masterpiece. It was a large, beautiful watch, completed in 1759. It used a fast-beating balance wheel and compensating metals that were immune to changes in temperature or the rocking motion of a ship. On a transatlantic voyage, it performed brilliantly, losing only a few seconds over many weeks. This single, patient, and perfect machine conquered time at sea, and in doing so, changed the world forever. Geologists perceive time on a scale so vast it is known as deep time, where mountains rise and oceans vanish like passing thoughts. Our human lives are measured in decades, our civilizations in millennia, but the Earth is 4.5 billion years old. To comprehend this, geologists use a different clock, one measured in eons, eras, and periods. On this timescale, processes that seem static become dynamic. The Himalayas, which seem the very definition of permanence, are the geologically recent result of the Indian subcontinent colliding with Asia, a slow-motion crash that is still pushing the mountains higher. The Atlantic Ocean is a young feature, a rift that began to open only about 180 million years ago, separating continents that were once locked together in the supercontinent. Pangea, entire species emerge, flourish for millions of years, and are then erased, becoming thin layers of rock. To see the world in deep time is to see it not as a solid place, but as a slow, breathing, liquid process, a grand, unfolding story written in stone. There is a clock being built inside a mountain in Texas that is designed to tick only once per year for 10,000 years. This is the Clock of the Long Now, a project conceived by Danny Hillis. It is a monumental piece of mechanical engineering intended as an icon for long-term thinking. The clock is designed to be a symbol that forces us to reconsider our relationship with time and the future. It is powered by the thermal energy of day-night temperature changes, and it is built from durable, stable materials like titanium and stone. The clock's bell chime is designed by the musician Brian Eno, and it will generate a different, unique sequence of notes every day for the entire 10,000-year span. A song that will never repeat. The mechanisms move slowly. The century hand ticks once every 100 years, and the cuckoo will emerge only once per millennium. It is a quiet, patient machine, waiting in the dark, asking a profound question to a future we will never see. The 24-hour news cycle, introduced in 1980, fundamentally altered our social perception of time's pace. Before the launch of CNN, news was a finite daily event. It arrived with the morning paper and was summarized in a 30-minute broadcast in the evening. The time in between was, by default, not news time. The 24-hour cable news model created an endless, continuous present. It demanded a constant stream of content to fill the void, transforming minor events into breaking news and shrinking the half-life of a story from days to hours or even minutes. This constant, urgent flow of information created a social present shock, a feeling that the world is accelerating and that one can never truly catch up. The rhythm of events was replaced by a constant, high-frequency hum of information. This technology effectively compressed our sense of the present, creating a new, restless, and immediate social time, a now that is always happening and always updating. On June 29, 2022, the Earth completed its fastest ever rotation, recording the shortest day in modern history. While the long-term trend is that the Earth's rotation is slowing down, in the short term, it fluctuates unpredictably. The planet's spin can be minutely sped up or slowed down by the movement of mass on its surface. Factors like the melting of polar ice caps, the sloshing of the Earth's molten core, and even large-scale weather patterns can alter the planet's moment of inertia, like a figure skater pulling in their arms to spin faster. On that day in 2022, the Earth completed its spin 1.59 milliseconds faster than the standard 24 hours. This trend of a slight, temporary acceleration has puzzled scientists and has even opened a debate about whether we might one day need to introduce a negative leap second for the first time, removing a second from the clock to keep it aligned with the planet's hurried spin. Our world is a living, dynamic system, a great spinning top that subtly wobbles as its oceans, ice, and core are in constant, restless motion. Some physical theories predict a future where time itself will lose all meaning, a state known as heat death. This idea stems from the second law of thermodynamics, which states that entropy or disorder in the universe is always increasing. This is the arrow of time we experience. If the universe continues to expand forever, it will eventually reach a state of maximum entropy. In this unimaginably distant future, trillions upon trillions of years from now, all stars will have burned out. All matter will have decayed into a thin, cold soup of elementary particles, distributed uniformly throughout the vast, dark expanse. In this state of perfect equilibrium, there will be no more order to become disorder. No complex processes can occur. In this heat death, with no change possible, the concept of before and after would become meaningless. The arrow of time would have nowhere left to fly and the cosmos would settle into a final endless and static now. The first mechanical clocks had no faces or hands. Their only purpose was to ring bells and announce the time to the public. These massive, weight-driven clocks appeared in European towns in the late 13th and 14th centuries. They were not personal devices, but enormous public machines installed in towers. Their primary function was to regulate the canonical hours for prayer in the local monasteries, ringing a bell to call the monks to service. Soon, this sound began to regulate all of civic life. It told merchants when to open their shops, laborers when to start and stop their work, and town guards when to close the gates. This was a profound shift. Before this, time was seen by the sun or felt by the stomach. Now, for the first time, time was heard. It became an abstract, external, and uniform signal that segmented the day into equal, audible portions. The ringing of the clock tower was the first great metronome of the modern world, a new, mechanical heartbeat that gathered all of society into a single, synchronized rhythm. The clock in Salisbury Cathedral in England is believed to be the oldest working clock in the world, ticking since 1386. This remarkable machine is a massive iron-framed mechanism, built without a dial, as its purpose was to strike a bell for the hours of prayer. It was constructed just as the concept of equal 24-hour time was emerging. It has a verge and foliot escapement, the earliest known type of mechanical timekeeper. This mechanism, a brilliant invention of the medieval mind, regulates the release of energy from the heavy, driving weights. The clock ticked in the cathedral tower for nearly 500 years until it was replaced in 1884. It was rediscovered in an attic in 1928, forgotten and dusty. After being carefully restored in 1956, it was set ticking once more. Today, it operates in the cathedral nave, its ancient gears turning, its great wheels slowly counting the seconds. It is a living piece of the 14th century, a tangible, rhythmic connection to a time when our mechanical mastery of the day was just beginning. The flash lag effect is an optical illusion that reveals your brain is constantly predicting the immediate future. This illusion occurs when you see a moving object, and a second object is briefly flashed in the exact same physical location. To our perception, the moving object appears to be ahead of the flashed object, even though they were in the same spot. This is not a mistake by the eyes, but a clever strategy by the brain. There is a slight delay, perhaps 1/10 of a second, between light hitting your retina and the signal being fully processed by your brain to compensate for this neural lag and allow us to interact with a moving world. The brain generates a prediction. It extrapolates the moving object's path and shows you where it should be in the next instant, rather than where it was a moment ago. The present you are seeing is not a perfect recording of reality, but a predictive simulation, a best guess, created by your mind to keep you perfectly in sync with a world that is always one step ahead. Mountains are in a constant, imperceptibly slow battle between tectonic uplift and the erosion of time. We see mountains as symbols of eternal stillness, but in geological time, they are dynamic. The uplift is the process of tectonic plates crashing together, forcing rock upward to create peaks. From the moment that rock is exposed, erosion begins its patient work. Water, in the form of rain and ice, is the primary sculptor. It seeps into tiny cracks, and when it freezes, it expands. Wedging the rock apart, rivers carve deep valleys, carrying away sediment. In a very active range like the Himalayas, the uplift is currently winning, and the mountains are still growing. In older, more ancient ranges like the Appalachians, erosion has long since won, and the once mighty peaks have been worn down into gentle, rolling hills. Every mountain range is a temporary story, a long, slow-motion wave rising from the Earth's crust, and then just as slowly, particle by particle, being washed back into the sea by the patient, relentless hands of time. Many people with ADHD experience a phenomenon known as time blindness, a consistent difficulty in perceiving the passage of time. This is not a matter of carelessness or a lack of trying. It is a neurological difference in how the brain's executive functions manage and track time. For many people, time is perceived as a linear, tangible thing that can be felt, passing. For someone with time blindness, time is often experienced only as now or not now. This can make it incredibly difficult to judge how long a task will take, to feel the weight of a deadline that is in the future, or to accurately remember how long ago an event happened. It can lead to chronic lateness or a feeling of time slipping away, as the internal metronome that most people rely on is either absent or unreliable. This reveals that the sense of time is a complex cognitive skill, an intricate construction of the brain, as vital and as variable as any of our other senses. The Great Year is a vast 26,000-year cycle caused by the slow wobble of the Earth's axis. This wobble, known as axial precession, is a tiny conical motion of the planet's rotational axis, similar to the wobble of a spinning top as it slows down. It is caused by the gravitational pull of the Sun and the Moon on the Earth's slight equatorial bulge. The most famous effect of this slow drift is that our North Star changes over time. Today, the axis points toward Polaris, but 13,000 years ago, it pointed toward the star Vega. In another 13,000 years, Vega will be the North Star once again. This precession also causes the timing of the equinoxes and solstices to slowly shift around the Earth's orbit. Ancient astronomers, like Hipparchus, were the first to discover this precession of the equinoxes, a discovery that revealed a new, grand celestial clock, a slow, majestic turning of the heavens that dwarfs all human timescales. There is a popular myth that glass is always slowly flowing, like a liquid frozen in motion, and that the thick bottoms of old cathedral windows are proof of this. In reality, glass at ordinary temperatures behaves as a solid. Those uneven panes are the result of imperfect medieval manufacturing, not centuries of dripping glass. Yet glass is also not a neat crystal. It is an amorphous solid, a frozen tangle of atoms that never quite settled into an orderly pattern. Over unimaginably long timescales, the internal structure of glass can very slowly relax, its atoms shifting by tiny amounts as it drifts toward a more stable arrangement. This process is so slow that, to us, it is indistinguishable from stillness. It may take longer than the age of the universe for the change to matter. Even here, time is quietly at work at the atomic level, not as a visible sag or flow, but as a patient smoothing of disorder that continues in silence, long after every human eye has looked away. The International Fixed Calendar was a proposed calendar reform that featured 13 identical months. Put forward by Moses B. Cotsworth in 1902, it was designed to be a perfectly simple and rational system. In this calendar, every month had exactly 28 days, and every month began on a Sunday and ended on a Saturday. This meant that every month was a perfect 4 weeks. The 13 months were the 12 we know, plus a new month called Sol. which was inserted between June and July. This system accounted for 364 days. The 365th day, year day, was an extra day tacked onto the end of December, which belonged to no month and no week. A leap day was similarly added during leap years. This elegant, logical calendar was seriously considered by the League of Nations in the 1920s and was even adopted for internal use by the Eastman Kodak Company for decades. It remains a beautiful what-if in the history of timekeeping, a dream of a perfectly orderly year. The Paleocene-Eocene thermal maximum was a period of catastrophic, rapid global warming that occurred 56 million years ago. This event, known as the PETM, saw global temperatures surge by 5 to 8 degrees Celsius or 9 to 14 degrees Fahrenheit in just a few thousand years, a geological instant. The cause is believed to have been a massive release of carbon into the atmosphere, though the exact source is still debated. This sudden, intense warming acidified the oceans and led to a major extinction event, especially in the deep sea. It took the planet over 150,000 years to slowly reabsorb the excess carbon and return to its previous climate. The PETM is a profound and sobering story from Earth's deep past. It serves as a stark warning, a message written in ancient rock layers, demonstrating how a rapid change in the atmosphere can violently disrupt the planet's equilibrium, a climate fever dream from which the world took millennia to awaken. In Japan, the kintsugi art form treats the mending of a broken object as a celebration of its history, rather than a disguise of its wounds. When a piece of treasured pottery, like a bowl or a cup, is broken, it is not thrown away. Instead, it is meticulously reassembled by a master craftsman who uses a special lacquer mixed with powdered gold, silver, or platinum. The cracks are not hidden. They are highlighted, transformed into beautiful, shining rivers of gold. This philosophy, which is related to the concept of mushin or no mind, accepts change and damage as an inevitable and valuable part of an object's life. The breakage and repair are treated as part of the object's story, not the end of it. The object is considered more beautiful and more precious because it has been broken and lovingly restored. Kintsugi is a physical meditation on time, resilience, and the beauty of imperfection, a testament that time's scars can be veins of gold. The Antikythera mechanism is an ancient Greek analog computer, a 2,000-year-old machine of astonishing complexity. Discovered in a Roman-era shipwreck in 1901, this corroded bronze device was so advanced that its true purpose was not understood for decades. It is a clockwork mechanism of at least 30 interlocking, precisely engineered gears. When a user turned a hand crank, the gears would turn dials on the front and back, accurately predicting the positions of the Sun, the Moon, and the 5 known planets. It could model the irregular, elliptical orbit of the Moon, predict solar and lunar eclipses, and even track the 4-year cycle of the ancient Olympic Games. It is a mechanical cosmos, a philosopher's guide to the heavens. It stands as a stunning testament to the lost technological knowledge of the ancient world, a silent bronze survivor that whispers of a time when astronomy and engineering were one, and the universe was a great celestial clock. The mayfly is an insect whose entire adult life is a desperate race against time, lasting, for some species, only a few hours. These delicate aquatic insects spend almost their entire lives, 1 or 2 years, as nymphs, living on the beds of clean rivers and streams. When they are finally ready, they undergo a hatch, emerging from the water in a massive synchronized swarm. They transform into winged adults, but with a fatal design. They have no functional mouths or digestive systems. Their only purpose is to reproduce. They have just the energy stored from their nymphal life to fly, find a mate, and lay their eggs back on the water's surface. For some species, this entire winged adult phase lasts less than a day, sometimes only 5 minutes. It is the ultimate expression of an ephemeral life, a creature that is a living, breathing, flying moment, a brief, beautiful song that ends almost as soon as it begins. Its entire existence a sacrifice for the next generation. The long-term U2 reconnaissance was a secret program that lasted for decades, creating a time capsule of a changing world. Starting in the Cold War, high-altitude U2 spy planes flew missions over vast stretches of the globe, taking high-resolution photographs. While their original purpose was military intelligence, these missions inadvertently created an unparalleled scientific and historical archive. The photographs, stored for decades, became a B-roll of 20th century history. When declassified, scientists realized they had a treasure. By comparing these old photographs to modern satellite images, they could precisely track the passage of time on the Earth's surface. They could watch glaciers in Greenland shrink, see the city of Dubai rise from the desert, and measure the alarming, decades-long drying of the Aral Sea. This accidental record, born of conflict, became a serene, objective witness, allowing us to watch the slow, sweeping changes of our planet over half a century. A light year is a measure of immense distance, not time. It is a common point of confusion, but the year in its name refers to the time it takes for light to travel. It is the total distance that a beam of light, moving through a vacuum, will cover in one single Julian year. This distance is staggering, about 5.88 trillion miles, or 9.46 trillion kilometers. This unit is used by astronomers because the distances in space are too vast to be measured by familiar units. To say the nearest star system, Proxima Centauri, is about 25 trillion miles away is a number too large to hold. But to say it is 4.24 light-years away is a more graspable, more poetic concept. It frames the distance in terms of a journey. It is a measurement that inherently carries within it the concept of look-back time, reminding us that to look at that star is to see light that is already over 4 years old. The song of the humpback whale is a cultural tradition, an oral history that evolves over time. These complex, haunting songs, which can last for 30 minutes, are sung only by the males, and all the males in a single population will sing the same song in any given season. However, the song is not static. Over months and years, it slowly evolves. The whales will add new notes, change the phrasing, or drop entire sections. This change is gradual and collective. Then, sometimes, a revolutionary new song will be introduced from a neighboring population, and the local whales will rapidly abandon their old song and adopt the new, fashionable tune. This is a clear example of cultural transmission in a non-human species, a hit song passing from one group to another across an ocean. The song is a living, shared memory, a slow, melodic chronicle of their time, passed down through the deep, blue silence of the sea. In 1915, Einstein's theory of general relativity suggested that the orbit of Mercury was wobbling because of how time is warped by the Sun. For decades, astronomers had been puzzled by Mercury's orbit. It did not perfectly follow the laws of Isaac Newton. The planet's elliptical path slowly rotates over time, a precession that could not be fully explained by the gravitational pull of the other planets. there was a tiny, baffling discrepancy of 43 arcseconds per century. Some astronomers even hunted for a phantom planet, Vulcan, that they believed was hiding near the Sun, its gravity tugging on Mercury. But Einstein's new theory provided the true, beautiful answer. The Sun's immense mass warps the fabric of space-time around it, and the flow of time itself is slightly slower closer to the Sun. Mercury, orbiting in this warped gravity well, is simply following the curved path of a universe where time and space are not flat. That tiny 43-second wobble was the first profound confirmation of a new cosmic gravitational time. The Flynn effect is the observation that human intelligence, as measured by IQ tests, has been steadily increasing over time. This trend, observed across the 20th century in many parts of the world, shows that each generation has scored significantly higher on standardized tests than the generation before it. The average person in 1980, for example, would score as a genius if they were to take an IQ test from 1920. The reasons are not fully understood, but are likely not due to genetic evolution, which is far too slow. Instead, it is believed to be a reflection of a changing environment, better nutrition, more widespread and complex education, and a world that increasingly demands abstract thinking, such as visualizing, rotating, and categorizing, have all contributed. This effect suggests that intelligence is not a static measure, but a fluid potential, sculpted by the changing demands and opportunities of the time in which a mind is raised. The biological clock that controls aging may be linked to the slow shortening of telomeres at the end of our chromosomes. Telomeres are protective caps on the ends of our DNA strands. Often compared to the plastic tips on shoelaces, they protect the vital genetic information from fraying every time a cell divides. However, with each cell division, these telomeres become slightly shorter. When they become critically short, the cell can no longer divide safely and enters a state of senescence or old age, or it self-destructs. This slow mechanical erosion of the telomeres acts as a kind of cellular countdown, a clock that measures the replicative history of a cell. This process is a major component of aging. It is the patient, molecular timekeeper of our tissues, the internal clock that measures not the hours of the day, but the number of permitted lifetimes a cell has left to live. The Little Ice Age was a period of regional cooling that lasted for several centuries, profoundly shaping human time. From roughly the 14th to the 19th century, parts of the Northern Hemisphere, especially Europe and North America, experienced significantly colder winters. This was not a true ice age, but a subtle, sustained shift in the global climate, likely caused by a combination of factors, including reduced solar activity and volcanic eruptions. This cooling had dramatic effects on history. It caused crop failures and famines, which contributed to social and political unrest. The River Thames in London froze over so solidly that frost fairs were held on its surface. This period demonstrates that human history does not unfold on a static stage. Our civilizations are built upon a thin, fragile layer of climate stability. A change of only 1 or 2 degrees in the global average, sustained over time, is enough to rewrite the course of our story, moving armies and toppling kingdoms. The Doomsday Clock is a symbolic timepiece, created by atomic scientists in 1947 to represent humanity's proximity to global catastrophe. Maintained by the Bulletin of the Atomic Scientists, the clock is a metaphor, not a prediction. Midnight represents a human-made doomsday. The minutes to midnight are a measure of how vulnerable our world is to annihilation, primarily from nuclear weapons, but now also from climate change and disruptive technologies. The clock was first set at 7 minutes to midnight. It has been moved backward and forward over the decades, reflecting the shifting tides of global politics. It was furthest from disaster in 1991, at 17 minutes after the end of the Cold War in recent years. It has been moved perilously close, reflecting new, complex threats. It is a sober, public-facing timepiece, a constant, solemn reminder from the scientific community that the time we have left to act is not infinite, and that the hands are moving. There is a fundamental limit to how fast any process can happen, defined by the Bremerman limit. This is not just a limit on motion, like the speed of light, but a limit on computation and information itself. Based on quantum mechanics and relativity, the limit states that no system, including a computer, can process information faster than a certain rate, which is about 1.36 times 10 to the power of 50 bits per second per kilogram of mass. This is an almost unimaginably large number, but it is not infinite. It implies that there is a maximum frame rate for reality itself. It suggests that a given piece of matter can only experience a finite number of changes or events within a given amount of time. This ultimate speed limit of the universe sets a boundary, not just on our technology, but on the very pulse of reality. It means that even time itself, in its expression as change, has a maximum finite speed. The nostalgia we feel is a form of time travel, a cognitive mechanism that the brain uses to regulate our emotions. Nostalgia, the pain for a lost home, was once considered a psychological illness. Today, it is understood as a complex and highly positive human emotion. It is a bittersweet feeling, a gentle sadness for a past that is gone, mixed with a warm, profound sense of joy and social connection from having experienced it. Psychologists have found that nostalgia serves a vital purpose. When we feel lonely, bored, or anxious in the present, our brain often triggers a nostalgic memory. Recalling this positive social memory, a family holiday, a moment with old friends, can restore our sense of belonging, increase our optimism about the future, and provide a feeling of continuity, a sense that I am still the person who lived that happy moment. It is the mind's own time machine, a healing anchor it drops into the golden harbors of our past. The great library of Ashurbanipal from ancient Assyria was an attempt to collect and freeze all the knowledge of its time. In the 7th century BC, the Assyrian king Ashurbanipal assembled a vast collection of texts in his capital, Nineveh. He sent scribes to every corner of his empire with a remarkable command: to collect and copy every known book, tablet, and manuscript. This was not just a royal hoard. It was a systematic, scholarly attempt to create a universal library, to stop time and preserve the sum of human wisdom, from magic and medicine to literature and astronomy. When Nineveh was destroyed, the library was buried. Thousands of clay tablets were accidentally fired in the blaze, baking them solid and preserving them for 2,500 years until they were excavated in the 19th century. This time capsule of knowledge, born from one king's ambition, gave us our most complete understanding of Mesopotamian civilization, including the famed Epic of Gilgamesh. The Standard Model of particle physics, our most successful theory of matter, does not naturally include the arrow of time. This profound theory beautifully describes all the known fundamental particles and their interactions. However, as with most laws of physics, its core equations are almost entirely time-symmetric. They work just as well backwards as they do forwards. The one-way direction of time, which is so fundamental to our human experience, does not emerge from this model. The only exception is a tiny, subtle violation of this symmetry, seen only in the behavior of certain weak force particles. But this small effect is nowhere near large enough to explain the powerful universal arrow of time that governs our entire macroscopic world. This leaves physics with a deep mystery. The forward flow of time, the irreversible unfolding of cause and effect, is not a property of the parts, but a profound, emergent property of the whole universe, a system-wide behavior that is still not fully understood. The Mawson's huts in Antarctica are a perfectly preserved time capsule of the heroic age of exploration, frozen in 1913. These wooden huts, built by the Australasian Antarctic Expedition, led by Douglas Mawson, stand at Cape Denison, a location so windy it is known as the home of the blizzard. When the expedition ended, the huts were abandoned, but the intense dry cold and the deep, blanketing snow preserved them perfectly. When archaeologists re-entered the huts decades later, they found a scene frozen in time. Bunks still had blankets on them, shelves were stocked with tins of food, and scientific instruments lay on benches, as if the explorers had just stepped out. It is a silent, poignant stage set. The absence of decay has created a perfect static memory, a fragile human moment from over 100 years ago, protected from the flow of time by the vast, sterile cold of the Antarctic continent. A black hole's event horizon is a place where time, for an outside observer, appears to come to a complete stop. This is the most extreme example of gravitational time dilation. As an object, like a spaceship, falls toward this boundary, a distant observer would see it move slower and slower, its light becoming redder and redder until it seems to freeze at the edge, its image smeared out and fading over an infinite amount of time it would never be seen to cross. However, for the unfortunate traveler in the spaceship, time would feel perfectly normal. They would feel no pause, no slowing. They would cross the event horizon in a finite and likely very short amount of time, unaware that from the perspective of the universe they left behind, their final moment has been stretched into eternity time. In this warped region, splits into two irreconcilable realities. The microscopic tardigrade, or water bear, is a master of suspended time, able to enter a state of profound metabolic stillness. When faced with extreme, life-threatening conditions, such as total dehydration, freezing temperatures near absolute zero, or the vacuum of space, this tiny animal can enter cryptobiosis. It retracts its legs, curls into a small, dry ton, and effectively stops its own biological clock. Its metabolism slows to less than 0.01% of its normal rate. In this state, it is not truly living, but it is not dead. It is waiting. The flow of its internal time is almost completely arrested. Tardigrades have been revived from this state after 30 years, awakening from their suspended decade, rehydrating, and walking away as if no time had passed at all. They are a living demonstration that time, for life, is not a constant, but a fire that can be banked to a mere ember, waiting patiently for the right conditions to glow once more. There was a period in Earth's history, lasting for roughly 1 billion years, where evolution itself seemed to pause. This era, appropriately named the Boring Billion, stretched from about 1.8 billion to 800 million years ago. After the initial excitement of life's emergence and the rise of simple cells, the planet settled into a long, quiet stasis. The atmosphere, the oceans, and the climate were remarkably stable. The simple, single-celled life forms that dominated the world, like bacteria and algae, did not seem to change or evolve in any significant way. The great dance of complex, multicellular life was still hundreds of millions of years in the future. This vast, silent eon is a puzzle for scientists. It serves as a profound reminder that time's passage does not guarantee progress or change. Sometimes, the clock of the world can tick for 1 billion years, and in the grand scheme of life, almost nothing happens at all. The modern concept of daylight saving time was first implemented as a wartime measure to conserve energy. During World War I, Germany and its allies were the first to spring forward, shifting their clocks by an hour in 1916. The goal was to reduce the evening use of artificial lighting, thereby saving precious coal for the war effort. Other nations, including Britain and the United States, quickly followed suit. The idea itself was older, having been jokingly proposed by Benjamin Franklin and more seriously by a British builder. William Willett, who loved early morning golf today, the practice is a subject of great debate. Many studies question whether it still saves any energy and point to the health disruptions caused by abruptly shifting the social clock twice a year. This twice-yearly leap is a modern invention, a massive coordinated manipulation of our shared clock time in an attempt to better align our lives with the slow seasonal tilting of the planet. The oldest light in the universe, the cosmic microwave background, comes to us from a specific moment in time known as the surface of last scattering. This is not a physical wall in space, but a wall in time for the first 380,000 years after the Big Bang. The universe was an impossibly hot, dense, opaque fog of plasma. Photons, or particles of light, were instantly scattered by free-roaming electrons, unable to travel freely. The cosmos was dark, but as the universe expanded, it cooled. When it reached a temperature similar to the surface of a star, the electrons were finally calm enough to be captured by protons, forming the first stable hydrogen atoms. Suddenly, the universe became transparent. The photons that were set free at that exact moment have been traveling, unimpeded, ever since. This first light is the cosmic microwave background. When we look at it, we are seeing the afterglow of that first sunrise, a perfect ancient photograph of the universe at the moment of its dawning. Cosmological theories about the ultimate fate of the universe also describe the end of time itself. There are several competing ideas. One is the Big Crunch, a scenario where the universe's expansion, pulled by gravity, eventually slows, stops, and reverses. Galaxies would rush back together, and the cosmos would collapse into a final, infinitely hot and dense singularity, a reverse of the Big Bang, where time and space cease to exist. A more likely scenario, given our current understanding of dark energy, is the Big Rip or heat death. In this future, the expansion accelerates, pulling everything apart. First, galaxies will be torn from each other, then stars from their planets, and finally, atoms themselves will be ripped apart. This leads to the heat death we explored, a cold, empty universe in maximum disorder, where no change is possible, and the arrow of time has no meaning. These theories are the universe's grand final act, a story that ponders whether the river of time eventually flows back into its source, or simply widens into a still, endless, and silent ocean. The year 46 BC is known as the Year of Confusion, and it was the longest calendar year in human history, lasting for 445 days. This colossal year was an administrative necessity, the result of Julius Caesar's sweeping reform of the Roman calendar. The old Roman calendar was a lunar-based system that had drifted wildly out of sync with the solar seasons. By 46 BC, the winter months were falling in the middle of autumn. To correct this, and to prepare for the introduction of his new sun-based Julian calendar, Caesar had to add 2 extra intercalary months between November and December. He also added another 23 days after February. This one-time massive correction of 90 extra days was needed to realign the calendar with the sun, so that the new year, January 1st, 45 BC, could begin on the correct seasonal date. It was a reset of time itself. A year deliberately stretched to an unnatural length to fix centuries of accumulated temporal drift. In Einstein's relativity, an object's path through the 4 dimensions of space-time is called its world line. We are used to thinking of our existence in 3 spatial dimensions: length, width, and height. But in physics, time is the 4th dimension, inseparable from the other 3. A world line is the unique 4-dimensional story of an object's entire existence. If you are sitting perfectly still, your world line is a straight line, moving only forward through the time dimension. If you walk across the room, your world line becomes a gentle curve, as you are changing your coordinates in both space and time. It traces not just where you are, but when you are there. From this perspective, your entire life, from the moment of your birth to the moment of your death, is a single, complete, and unchanging line in the block of space-time. This concept is a profound shift, suggesting that all of an object's history exists at once, a finished tapestry viewed from a higher, timeless perspective. A time signature in music is a beautiful and simple piece of code that organizations of the flow of time into a felt, rhythmic pattern. Written as a fraction, like 4/4 or 3/4, it is the fundamental heartbeat of a piece of music. The bottom number tells the musician what kind of note gets 1 beat, and the top number tells them how many of these beats are grouped together to form one measure. A 4/4 signature, the most common in popular music, creates a steady, reliable pulse of 1, 2, 3, 4. A 3/4 signature creates the gentle, rolling pulse of a waltz, 1, 2, 3. This framework does not define the speed or tempo, but rather the gait of the music. It is the architectural blueprint for rhythm, the loom on which all melody and harmony are woven. It is a purely human invention, a way to take the abstract, linear flow of Chronos time and sculpt it into a repeating, structured, and emotional kairos that we can feel in our bodies. The effectiveness of many medicines is deeply connected to the time of day they are taken, a field known as chronopharmacology. Our body is not a static system. It is a symphony of circadian rhythms over a 24-hour cycle. Our body temperature, hormone levels, blood pressure, and even the stickiness of our blood platelets change in predictable waves. Our internal clock dictates that some processes are more active at night and others during the day. Medical science is now learning to use this. For example, since heart attacks and strokes are most common in the early morning, taking aspirin or blood pressure medication at bedtime can provide the maximum protection when it is most needed. Likewise, some chemotherapy drugs are more effective and less toxic if administered at a specific time of day. when the cancer cells are most vulnerable and the healthy cells are most robust. This is a new, gentler medicine, one that seeks to synchronize its healing power with the body's own ancient, internal rhythms. There is a piece of music called long player that is designed to play continuously without repeating for 1,000 years. This composition, conceived by artist Jem Finer, began playing at midnight on January the 1st, 2000, and it is not scheduled to complete its first cycle until December 31st, 2099. It is based on a 20-minute and 20-second source piece, which is transcribed for a set of 234 Tibetan singing bowls. The music is generated by a computer algorithm that performs a vast but simple set of calculations on this source music. This process ensures that while the music is always, in a sense, the same, the combination of notes and patterns will never repeat over the 1,000-year span. The piece is a living, audible sculpture of deep time. It can be heard in a lighthouse in London, and it streams globally on the internet, a calm, quiet, and endlessly unfolding melody, and now that is designed to connect our present moment to a future 100 centuries away. Deep inside a frozen mountain on a remote Arctic island, the Svalbard Global Seed Vault stands as a silent ark, a time capsule of agricultural biodiversity. This vault is a vast frozen library built to protect the world's food supply from the erosions of time, disaster, and change. It holds duplicate backup copies of seed collections from gene banks all over the world. Its mission is to safeguard the genetic map of our planet's crops, from countless varieties of wheat and rice to barley and corn. The vault is built to last for centuries, its storage rooms chilled by the natural permafrost of the mountain. It is a profound act of foresight. It is a quiet admission that civilizations can fall and environments can collapse, but that the memory of our food, the genetic code of our sustenance, must be protected. It is a seed of hope locked in ice, waiting patiently in the dark for a future time that may one day need it to begin again. There is a small Amazonian tribe, the Amondawa people of Brazil, whose language appears to have no abstract concept for the passage of time. Linguists who have studied them have found that their language lacks words for time as a general concept, or for units like month or year. They do not speak of next week or last year. This does not mean they are stuck in the present. Instead, they seem to live in a world of events, not of abstract time. They will speak of the rainy season or harvest time, but as a description of the environment, not as a point on a calendar. They do not have clocks or calendars, and even their age is not counted. A person changes their name as they move through different stages of life, from childhood to adulthood, to mark their new role in the community. Their language suggests a different worldview, one where time is not an empty river containing events, but is simply the sequence of the events themselves. The ancient, stony structures of coral reefs are not just rocks. They are living, growing superorganisms whose time is measured in millennia. An individual coral polyp is a tiny, soft-bodied animal, but these polyps grow in vast colonies, and they build a shared hard skeleton of calcium carbonate beneath them. As new polyps grow on top of the old skeletons, the reef structure expands year after year, century after century. Some of the massive reef structures we see today began growing over 5,000 years ago. Deeper in the cold, dark ocean, scientists have found colonies of black coral that are even older, with one specimen in Hawaii dated to be over 4,200 years old. These ancient branching structures are living chronicles of the ocean's past. Their skeletons hold a chemical record of the sea's temperature and composition, a library of the planet's climate, written slowly, layer by patient layer, in stone. A quantum leap is a transition that is truly, unimaginably instantaneous, a jump that happens outside of time. In the quantum world, an electron orbiting an atom cannot be in between energy levels. It must exist in one specific, quantized energy shell or another. When it moves from a lower shell to a higher one, it absorbs a photon. When it falls, it emits one. But the jump itself, the movement from here to there, is not a movement through the intervening space. The electron simply ceases to exist in one location and simultaneously appears in the new one. The process itself takes no time. We can never predict when a specific electron will jump. We can only know the probability that it might. This is the fundamental probabilistic weighting that defines the quantum world. Change, at this most intimate level, is not a smooth, gradual flow, but a series of discrete, abrupt, and timeless steps from one reality to the next. The Voyager 1 and 2 spacecraft, launched in 1977, are now drifting in the cold, silent emptiness of interstellar space, each carrying a golden record, a time capsule of humanity. These twin probes are the most distant human-made objects, and they will continue to drift through the Milky Way for billions of years. Attached to the side of each is a 12-inch gold-plated copper phonograph record. This bottle, cast into the cosmic ocean, contains a message for any civilization that might one day find it. It holds 115 images of Earth and human life, spoken greetings in 55 languages, and a 90-minute selection of music, from Bach and Beethoven to Chuck Berry, and traditional folk songs. It also carries the sounds of Earth, wind, rain, birds, and the sound of a human heartbeat. These records are humanity's most ambitious attempt at immortality, a quiet, golden hello that will long outlast our planet, our sun, and perhaps time itself. The feeling of boredom is a complex modern emotion that is, at its core, a painful awareness of the passage of time. Boredom is not the same as rest or leisure, which can be peaceful. Boredom is a state of agitation, a desire to be engaged, combined with an inability to connect one's attention to the environment. It is in this stuck state that we become acutely conscious of time itself. Without a task or a thought to fill it, time ceases to be the invisible background to our lives and becomes the foreground. We feel every second passing. It becomes heavy, slow, and oppressive. This is why a watched pot never boils. This modern feeling, born from a world that promises constant stimulation, is a time consciousness, a brief, uncomfortable moment where we are forced to look directly at the empty, mechanical, and relentless ticking of the clock, rather than the story that is meant to be written upon it. The philosophy of eternalism, which is supported by Einstein's physics, suggests that the past, present, and future all exist simultaneously and are equally real. This is sometimes called the block universe theory. In this view, our human perception of time as a flowing river, and our feeling that the present is the only moment that is truly real, is a deeply ingrained illusion. Instead, all of time is a single, vast, four-dimensional block of space-time. The past is not gone, and the future is not unformed. They are simply different locations in space-time, just as here is a different location in space from there. A person is not something that moves through time, but is a four-dimensional world line, a worm that stretches from their birth to their death. In this quiet, profound, and unsettling vision, all of history is a single finished sculpture, and now is just the narrow, moving spotlight of our consciousness, slowly illuminating one slice of it at a time. And so, our journey through the boundless, invisible world of time comes to a gentle close. We have drifted on its deep currents, from the first light of the cosmos to the slow, patient pulse of an atom. We have seen how it stretches and bends near a black hole, and how it is counted in the patient growth of a tree. We have listened to its rhythm in the gears of an ancient clock, and in the genetic memory of a cicada, waiting years in the dark for a few perfect moments in the sun. Time is the grand, silent story in which all other stories are written, the canvas on which the universe is painted. We have also seen how time lives within us, in the beat of our own heart, and in the language we use to build our past and future. It is the river that sculpts the mountains, and the quiet shadow that follows us through the day. It is the great shared rhythm of reality. As we settle into the darkness, we can let go of our own small, hurried measures of it. We can release the day's urgency and float, just for a while, on this ancient, steady, and unending flow that carries all things toward rest. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of time and the gentle music carry you softly into rest. Sleep well. Good night.